Hey everyone, this video is going to be the beginning of this particular build. Instead of kind of showing an end reveal like I normally do, I'm going to be doing something a little different for this one. I'll break it in parts a little bit so we can kind of see it come together. Uh, for those that don't realize, this is a Lian Li Evo XL. That's one of the reasons I also chose to do this video with this case, because it's a very popular case. So we'll go into part selection and some of the constraints I have for this build, and then I'll kind of give you a breakout of my thinking, and then we'll go into how I'm going to make it happen. Okay, so first off, this is an AM5 platform. This is the X670E Extreme. I did pick this board for this build because I'm going to be upgrading to the 9000 series in about a week or two. Okay, so I don't know if I will have the X870E boards in the Extreme format. I don't know when that's coming. I don't even know if it's coming. I assume it is. So I'm going to use the X670E one for, I guess, in the meantime. And I'm pretty sure, it'd be perfectly serviceable anyway. So with that said, I have it in the inverted position, or some people like to say upside down. Outside of that, I have a 4090 Strix that's on Heatkiller block, and I've already pre-installed a Heatkiller 420 on top and a Heatkiller 420 on the bottom. I'm using the Lian Li TL LCD fans for the bottom and the regular TL for the top. This build, if you haven't noticed, has Heatkiller radiators, Heatkiller CPU block, Heatkiller GPU block, and obviously it's going to have a Heatkiller CPU pump res combo. Reason being is this is a build for Heatkiller, Watercool Heatkiller. So that's why. They were nice enough to send some toys for me to play with. So I'm going to do a build with all their blocks and rads. So right away, you'll kind of see that I already planned it out. I plan to have my air come in from the bottom. These are reverse LCDs and exhaust from the top. Now, the side is empty because I'm going to create a reservoir mount using for the Heatkiller reservoir on the side, mounted to a distro, and then that will handle the pump res to the radiators, and then and the GPU block, and then I'm going to do something elsewhere for these runs to meet up with this and this port. I know it sounds totally confusing and didn't make sense right now, but I will now take you guys into Fusion, and you'll get a better idea what I'm trying to do. Alright guys, so we're on the computer. I have the CAD file for the Evo XL open. This is actually public. You can grab it from the Lian Li Evo website. They have it for some cases, not all. You'll see it in STP format, or sometimes it might be something else. But it's kind of cool that they offer this without you having to ask for it. Most companies are not going to give it to you unless you're a partner of some kind, or you want to make accessories or something like that. So it's cool that they put it out there. I mean, honestly, as a consumer, you're not exactly going to be able to produce it on your own, right? And the factories that make these cases often kind of, let these designs go, and that's why you'll see sometimes multiple brands making the same case. It's not because they're rebadging a case, actually. They're kind of just, the factory's like, hey, we're making this. Do you want to make one too? And, whatever. I don't want to go too much into it. So here, I pretty much know I'm looking for this bracket assembly, right? I mean, you can move all this stuff around. For those that don't know, Fusion is a free program. Unless you want to use it for commercial purposes, then you should buy a license. But I just have the free version open up here, and I'm focusing on this bracket because what I was telling you guys earlier is that I'm going to mount my reservoir on this bracket. So what I'll do is I'll isolate this bracket, and you can see that because I have the CAD, I can easily design something on here. I know where all the holes are, and that's essentially what I have over here. So this is just, you can just export this bracket into another file and then open it. So this is the bracket itself. So you'll see the bracket. So I've taken the measurements from the bracket and projected it up. You can watch some Fusion guys online. I'm not a professional at this, but I know it well enough to kind of do what I need to do. So right away, I made a sketch to where this is kind of the outline of the Heatkiller reservoir. This is the entire width of it, 70 millimeters. This inside are the mounting holes for the reservoir, which is why there's going to be a hole there. So if I hide the original body and I come in here, you'll see that I have screw holes passing through. Obviously, there are no runs on this yet, right? This is kind of just a mock-up. So what I usually do at this point is I make a cutout. So if I hide all this, and I'll show you guys, see this basic sketch, and I put on my test plate. Now that we're looking at the plate, my test plate, I cut these holes myself. I measured them, where their locations would be, and my plan is to mount the Heatkiller reservoir here, and then these ports are going to match the in and out that's on the res itself. I've already cut this out so I can show you guys what I mean. I've chosen these temporary mounting locations for screws to mount to the original plate, right, to the original body plate. I could use the 360s here and the 420s, but unfortunately I'm going to have some tube runs right here, water channels on here, this side and this side, so I can't put a screw there. I put them on the extreme ends. You're not going to see them from the front because if I put back, sorry guys, so this is the bottom of the distro plate, right, and this is the lid of the distro plate. So the screws will come through from here. You'll see that. It's an example here. Sorry guys, really struggling without my space mouse. It's like from here, for example, I'll put a mounting screw here and I'll make a thread on the rear of the acrylic plate, and that will be a good place to mount the screw. Like same goes for here, right, same goes for here. Well, that's too low, maybe like here. I have a screw here already, so stuff like that. So that will make it mount, and you won't see any of the screws because this will come in. So what I'll do now is I'll show you guys the plate. I've already cut it out. For those that are not aware, Fusion is also a CAM software. I know I'm kind of going off tangent here, but if I go to manufacturer, you can see that I've already made the tool paths for this cover plate, and I've cut that out on my CNC. So we'll go back to the PC now, and we'll mount it in place, and you can get a better idea what I'm trying to do here. All right, so you can see here I've cut out that plate I was talking about. This 3mm acrylic. Obviously, I do not suggest you mount a reservoir on 3mm acrylic. Even though this is backed into that metal piece, I would still not suggest it because it will crack over time, especially removing it around. It's just not good enough. Like at least 3mm, if you want to use 3mm, use 3mm aluminum. But anyway, so the point being is my Heatkiller radiator is up here. Sorry, reservoir, pump res is here now. And what I was trying to tell you guys from the beginning was that this is obviously not the right length, but I plan to say, for example, run one here, run one here, and then for the GPU, you can see I'm going to do something like that, and then something like that. Obviously, I'm going to have all 4 ports be at the same height, so it's a symmetrical look, right? So, and then for this portion, the CPU, I'm going to have both of them come out, hit something around here that will then connect these 2 ports, right? So that's pretty much the plan. So what I'll do now is I'm going to map out the ports here. I'll show you guys how I do that. And then I'm going to map out the ports in the front. That might really just be, I think that's really just finding the X here, right? Because the Y is variable. So, I'm sorry. No, the Y is not variable. The X is variable. So, yeah, so let's look into this part and let's get started. So I have the PC on its back. Right now, my focus is only to figure out a couple locations. These primarily being the GPU in and out and the radiator to this part. So I'm not including the CPU block at the moment. I'm going to go into why in a second here. But let's show you guys how I do this. Sometimes I would take I like to use metal tubing for this because the 90 is always perfect, right? So if I'm using a tube to, let's say I use a combination of fittings and tubes to mark this point, that 90 is always going to be perfect. So when I bend the perfect 90, it's going to fit. Or sometimes what I'll do is I even just build the whole fitting bridge. Obviously, not everybody has any fittings laying around, but I happen to have that. Additionally, The plan here, to clarify from before, is that this out, right? This out right here on the reservoir is going to go into this radiator, right? So there will be a run here, okay? Obviously, this is going to be adjustable, right? I mean, this can be lower down, can be higher up. So when I'm measuring this, I'm only going to have to figure out X for the radiators. You know, the Y can be varying. For the GPU, I can figure out the Y, and the X can be varying, right? Because I can move it a little bit over, move it a little bit. Ideally, I'm going to make sure that these tubes are equidistant from the reservoir, so that way it's symmetrical. But yeah, that aside, we're going to go out into this reservoir here. This reservoir is going to connect with a different block distro thing to this GPU mount. To the CPU. So there will be another thing floating over here, which will be the connection to this. This will come back out, go into the connector here that will then feed into the radiator on top. This radiator will come out, go into the GPU in, and then come out the GPU out, which will then return into the reservoir in. I know it sounds a little bit complicated, but rest assured, it's a very simple loop. So yeah, so that's what I'm going to do now. I'm going to figure out where these holes are, and I'm going to go back to Fusion and start drawing it up. So I'm back in Fusion. I have a general idea where the ports are going to be. Everyone's going to do this a little differently. So I'm doing it my way. Obviously, there can be better organization on this on the side, but that's aside from the fact. So starting off from this perspective, I'm going to draw just one 14mm hole, and we will say it is, according to my initial measurements, 19mm off to the side, and 230mm from the bottom. Alright, and the next hole is going to be 14mm, also 19mm. Actually, you know what, let's just make this, let me zoom in here, make this 16. I should keep it 14. Alright, so obviously people do that slightly differently. You don't do it the same way I do. So this distance is 71mm. This is the GPU, right? Like I said before, I can move the X in, the X out more. So what I'm going to do is, if my mouse would cooperate, I'm going to make it 20mm. Because on the other side, I think I'm 20mm out. So I'll make this 20mm from the side. And then these are the two GPUs, and we'll come here and we'll do a radiator. I'm obviously going to move this wherever I need it to go. But initially, let's just say, let's draw a hole here. We'll do 20mm from this line, from this side. And then for X, we can, for Y, we can put it wherever we want. So let's just say this is, let's do a measure. This is, how far? This is 230, right? So, So we'll move this 230. Come in here. So we'll also say that this is 230. So now you'll see that I don't have a model of the reservoir, but the reservoir is going to go here. It's 70mm. This is the amount. So I think I have that over here, right? Let me just project that into here if I can. So this is a 70mm line. And then we'll do another 70. Yeah, that's 70mm. So that's the res. So if I look at it, like I said, guys, everyone has a different process. Mine is not exactly the only way to do it. I just want to see here. We have from the width of the res. What is that going to be? Why is that bugging out so much? Because it went to the other. Hold on. Let me see here. That's strange. It's been a while. Let's see. What's the distance between? Why won't it let me measure the distance? Oh, because that's not a line. Duh. Alright, so let's draw a line down. Just want to see here. What's the distance? Distance between this edges. So it's 32. Approximately 32. We'll draw another line. and that's 31. So I guess we can move this over 20.5, right? And then we have 30, 31. We can move it over. You know what, let's just make it 21.5. And then we'll come down here, take another look. It's 3692. Yeah, you can see I can get very OCD about this. No, that's 31. 30.2. Alright, so let's just make it 21. To the naked eye, it's going to look about the same. So essentially, this port here and this port here, when I have the whole reservoir in, is going to be it's going to be exactly the same. It's going to look the same distance away. And then I'll just copy this onto this side. Because I can adjust the radiators, I can make this side, these ports, however I want them. I don't need to, you know, really worry about that. Because I can slide the radiator left, right on the case, right? So, and up, down is just the length of the tube. So that's simple enough. So now you can see I have 2 runs coming here, 2 runs coming here, and 2 runs down here. So now what I'm going to do is I'm going to work out how I'm going to run this one to here. And in my mind, I'm running this to... Okay, I have to remember the loop order in my head. But let me just create the channels for a second. Let me think about this real quick. I have to go look at the case again, because I kind of forgot what I was doing. So I was continuing this from yesterday. Okay, so new sketch. Let me label it so I know what it is later. I'll just project the ports up. This is just simply referring to a previous underlying drawing. I'm not, like I said before, I'm not the best person in Fusion, so I don't want to make a guide. So let's see. We'll just do a simple run of a 90 for now. We can always adjust this later. So this port's coming here. Let me delete that. So, offset. Alright. I will add the curve to this later. And then let's see, this one has to go... Obviously this one has to go here. We can almost mirror that. I'm betting I can mirror this. That's hard. Do it the hard way. So I'm thinking I could just mirror this side, but then I realize it's a little bit off. So we will just remove this. Offset. And I just want to see how far off I am from the edge. 14 millimeters. That's enough. 4. Okay, so what I'm calculating right now is how far this screw is going to be. So I'm going to have 2 millimeters blank space, and then 2 millimeters for the O-ring, so that's 4 millimeters. And then and the screws will come in at about another 5 millimeters. So I'm looking at 9 millimeters. So I still have 5 millimeters to the edge from where the center of my screw is going to be. That's essentially what that is looking at. And this will just come all the way around. So it's going to look like a square. Oh boy. Alright, so we'll see if we can make that look better later. You know what? Let's try to see if we can mirror this. How long is this line? This is, what was that, 172.65? Alright, so I don't know if this will go all the way. Let's see. Oh yeah, that's not going to make it. So we'll just do, you know what? Let's just do 120. You're not going to be able to see it. It's going to be at the top anyway, so let's just bring this up. I think that's a little taller than 120, but it's okay. We'll just trim it out. Alright, and here we go. We'll do 7. And then we'll do 7 again. Alright, so let's do a quick save. And now let's see if we can make this prettier looking. Okay, so let's clean up these lines a little bit. I'm gonna come here, we'll do a fillet for these. 10 should be enough. And then we'll do a 5. You don't want these super, like, angular lines, because when you go make the O-ring, it's gonna be a total pain in the ass. So you want to make these as, you want to add a slight curve to it. 10 is usually enough. Do a 5 just to make it simple, and then we'll do the same for down here. This is obviously very simple looking, considering it's not the highlight, and I kind of want it to kind of just kind of highlight that reservoir in there. I think this will do the job. These corners can be tighter, like if I did like maybe like, let's see if I did like a 5 and a 10. Let's see how that looks. So if I did 5 and a 10, I like to kind of, does that look better? Oh, I did 5 and a 10. Let's see, that did something. Alright, let's see. Oh, you know what? I'm okay with that. Alright, so we'll say okay to that. Then I'll just come in here. Is this my bottom piece? Yes. So we will now just, if it wants to participate. Let's see. Sometimes it doesn't like to participate. Alright. This thing of Fusion, sometimes you gotta zoom in. Otherwise you end up clicking the wrong, like that. Yeah, this is the one thing I don't like sometimes. If I have to hide a sketch, let's hide the sketch. Yeah, make it easier. Okay. Is it on the bottom? No. Okay. So rather than making it all one extrude operation, I'll just make it 2. So I like to do 7mm. Wait, hold on. Why is it still? Yeah, see, that's why you should actually just hide the sketches you're not working on, because then it becomes a total pain in the butt. So, yeah, okay, that makes it easier. You notice as I hide sketches, it makes it easier to select what I actually want. Otherwise, it kind of plays this guessing game. So what I'll do is I think there's a faster way of selecting all that, but I'll just do 7mm. I usually do 8. And depending on, if it's a reservoir, I won't do that many because it will actually blow. But 8 should be okay. I mean, 7 will be too. And you can kind of see that's my bottom, right? So now I'm going to bring the lid out, which is somewhere here. There's the lid. Okay. So I'm going to do another sketch. Wait, let me make sure my lid mount is the highlighted. And I will just put it on top of the lid here. Okay. So we will call this G14 ports. Right. So let's see, we can, there's my ports. Is that visible? Okay. So now we will project, and we will project where those ports are. You guys can kind of see how this is working. Like very quickly. I think these are already there. Right? Okay, so first thing we'll do is we'll just extrude these down. You might notice there's a blank space here. That's okay, because it's not going to be blank. It's going to be slightly extruded. We'll just do 6mm because that's the depth of material. And then I think I extruded this a little bit. What is this? Let's see. So what is this? 2mm. Yes, just enough for it to just sit in a little bit, so it's not sticking out. And then we'll just come here, create thread. Where's my thread? It's amazing. I didn't use Fusion for like 2-3 months, and I'm like forgetting where things are. Okay, so 1. No, let me select more faces. Okay, you know what? Select the faces first. 2, 3, 4. Come create thread. I really should do my shortcuts on this one. I didn't do the shortcuts on this machine. So BSP pipe thread G14. Okay, so there we go. That is generally, you can tell right there, there are the runs. But for me, this bottom piece is going to be, where's my, alright, so this bottom piece, did I label this? No. So I'll call that the plate. This is going to be black acrylic. If I can get that to show up. Okay, well, it's going to be glossy, kind of, but not that glossy. So it's black plastic glossy, so let's just apply that. You'll notice I didn't even download all the appearances. So we'll just put it on the bottom here. So that's black gloss, that's black. And the top will be kind of a gray tint, so we can, is there transparent? Anyway, but I'll leave it clear for now so I can just get a better idea. So here we go. I mean, this is pretty much, oh, duh. There's things I forgot. Alright guys, so one more thing. So we're going to do the screws. I totally forgot about that. I got distracted by the lid. Alright, so coming back to the Where's my plate? Okay, so coming back to the plate, that's why I kind of like it, keep it, that's why you should always remove, yes. That's why you should always keep it clear to the end, it's easier to see. So there's my plate. I'm going to do here, new sketch on the plate itself, making sure it's in the right part. I'm going to make sure the water channels are available. I'm going to highlight this whole thing, this thing, and this thing. And then what I'm doing now is I'm making the O-ring. So I'll do a 2mm offset. Alright. And then I'll offset it again by 4mm. I'll do the same for these guys. 2mm offset. And then another one for this one. You can't offset off something that's already offset, so that's why I'm not doing it off the other one. So, see, because if I try to offset off this, you can see that it shows one or more selected areas has been offset, right? So, because it's basing off this. So I'll just do 4mm. So essentially what I've done is I've created a 2mm gap, right? And then I'll take this part. This is where the O-ring's going to go. Come on, highlight. Highlight, highlight, highlight. Okay, so I'm just gonna do 0.5. There's a reason it's 0.5. It's not because the O-ring's, 1mm. It's a 2mm O-ring. I have to make it 0.5 because when I machine it, acrylic is not even. So I have to machine 0.5 and I'll measure the averages around what it comes down to. Then I'll make an offset on the CNC itself to then lower the end mill a little bit more to create that fairly even 1.2 to 1. Yeah, pretty much like anywhere from 1mm to 1.2. I'll do some stabbies. You guys will see that in the video later to kind of get the O-ring correct. And that's my O-ring. So now I'm gonna work on the lid, bring the lid back, or hide these sketches I don't need to see. Now I'm gonna make the screws. Let's see, make sure I'm in the right part. Okay. So I will do new sketch. I will project where the end of the O-ring is. So let me label this before I forget. I can't label it right now. So this sometimes doesn't come up as nice as I expect, but we will just come in here and get the edge. So yeah, unfortunately it doesn't always highlight the entire thing, and I don't want to over project things, so I don't want to click everything all at once. There's a lot of shortcuts in Fusion. I've yet to learn them all, but one day I will. I've been slowly practicing drawing more complex items, simply because I might not be able to machine those things, but I can definitely print them, and that brings more possibilities. So okay, so here we go. Now I have the projected O-ring. So what I'll do now is I'm going to do an offset, and this offset will be 4.5. And I mean, some people like to go a little further, but I think for me, if I go a little further, my screw's gonna fall off. So I'll do 4.5. And now it's about the matter of picking the perfect screw situation. Okay, so some screws I'm gonna have to put in myself, like this one right here. I can just tell I'm not gonna be able to follow a path, so I'm just marking that ahead of time. Okay, so this one I will call screw path. Oops, screw path. I'll do a quick save. Alright, so now it's time to add the screws. So I come here and I'll do create hole, and just let me select here. I'm going to use it tapped. It's going to be flat at the bottom. Is that threaded? Okay. Oops. Okay. So let's. Why is it not selecting the point that I like? Okay, so let me hide some of these sketches. Okay, I can't hide. Oh, Is that my screw path on top of the lid? Okay, yeah. Sometimes you gotta be careful. It's in the wrong sketch dimension, and then it's gonna be all messed up. Okay, so hole. So I'll put it here. Let's just say we'll start here. And then this will be an M4 screw, so it's gonna be 16 millimeters, so 16 millimeters wide. The head of the screw is 4.6. Obviously, depending on the screw you're using, some of these are gonna change. This will be 6. And it's giving me this error because it's thinking it's the M22. Obviously, we're going to use a 4 millimeter M4. So, and it's going to be flat at the bottom. And yeah, so that's just one right there. Then we'll come in here and we will do a chamfer because it's a countersunk screw. Right? So you can see right away this is by the edge. And that's why if I went even further out, I'm going to have a hole. So now what I'll do is this is one of the ways, the screw path, I'm at the height. There's another sketch here. Alright, so highlight all the certain features. I'm going to create pattern on path. I'll bring it back up to my screw path. And then I'll say the path is... Hold on, guys. I think I projected my search to somewhere else. Oh, my screw path is actually here. Oops. Okay, so that's why. Alright, so anyway, I gotta fix the location of that, but it's okay. So, well, let's use spacing so it's even. Let's just start with 32. And this is just a matter of picking how it's gonna look. Let's see. So obviously I'll adjust them as I feel need by need. Let's see. Let's come here. Let's keep going, keep going, keep going, keep going. All the way around. Obviously you want to get a look that's fairly symmetrical. So you might have to adjust the... So you can move it a little bit. I like to kind of have them... to see, what is that? Can I go a little further? Let's say I do 33 millimeter. I mean, I wouldn't go above 35. I mean, you'll see like some manufacturers like Biscuit or something put something that's like 40 millimeters apart. That's not really my thing, but I think I have most of it covered. You could actually go less than this, obviously, but I think that would do. And that pretty much, you guys can see, puts M4 countersunk screws all the way around. Right? So I'm going to do the same for these two. I'm not going to show you guys the whole slew of the process. I might refine it a little bit afterwards, but I'll pick up when I start doing the actual cutting.